Hello everyone. Today we're gonna talk about hash. Before we start coding, let me ask you a simple question. If I want to check whether a value exists, should I scan the entire array every single time? Of course not. In C programming, we often use something called DAT, direct address table, which already gone through in the previous video. It is really fast, simple, but it only works when the key is a small integer range. But what if the key is a string, or a big number, or even a combination of values? That's where unordered map comes in, and we call it hash at the same time. Well, unordered map, one key maps to exactly one value, and if the key already exists, the value is overwritten. On the other hand, unordered multimap, the one key can map to multiple values, which is perfect for grouping data. So this is how the unordered map and unordered multimap looks like, just so you know. Well, let's start with a very simple example, which is called existence check. So we're gonna input those key, which is names. And whenever we get those keys, I'm gonna throw in one in the value part. So in this example, we're gonna use the unordered map. Well, first things first, I'm gonna write down some names. We have four names in this example: Alice, Tom, Sunny, and David. I'm gonna save it. Well, I need the libraries. I need the vector. I need the string. Lastly, I need the unordered map. Well, first things first, we need to skim through n times to get the names. We need the vector with the string type. Call it names. And we need to open up the text file. With the read mode. There we go. And then I need the unordered map with the key is the string type and the value would be integer type. And I need to skim through names size. And this is how I mark the values to the unordered map, like just like the DAT. So we need the target to check the existence of the name. I'm going to test with Tom and Steve. So if we need the count method to check the existence, if count is 0, which means that we doesn't have the target name inside of the unordered map, I'm gonna, print out target doesn't exist in database. And then I'm gonna, finish this main function right away. Otherwise, I'm gonna print out target exists in the database. There we go. Tom exists in database. What about Steve? Steve doesn't exist in database. So this is how the existence check works using the unordered map. Well, let's move on to our next example. Our goal is to count how many times each name appears over here. So it's basically a frequency counting that we already gone through in the DAT part. So using unordered map, we map each name to its frequency in constant time. Finally, we scan the map once to find the name with the highest count. So in this example, in this test case, Tom comes out 4 times, Jane comes out once, Sonny comes out once, and Steve comes out twice. So the highest count must be Tom with 4 times. Well, first things first, I'm gonna write down some test case over here. So copy and paste it. I'm gonna save it. Well, just like the first example for today, we need the vector. I need the string. And I need the unordered map as well. Well, we need the vector with the string type. We call it names. And I need to open up the text file again. With the read mode. There we go. I need to throw in some names in the vector. And this is how we throw in the names to the vector. There we go. And I need the unordered map with the key with the string type, and I need the integer type for the counter value. And I need to skim through names size. And this is how we increment the counter value. But our goal is to find out the highest count and we call it maximum value with the smallest value so that we can update over and over. So if maximum value is smaller than this value, I'm gonna update it. There we go. And then you need to save the highest name as well. There we go. So if I print out the highest name with the maximum value, it must be Tom and 4. There we go. We are given multiple records. Each record contains a name, a department, and a salary. And notice that the same name can appear multiple times, like Alex. So name alone cannot be used as a key. To uniquely identify each record, we combine the name and the department into a single key. This is done using a make key function. So the key looks like this: name plus separator like comma plus department. So we store the salary using this combined key inside an unordered map, as you can see. So now when we query with the name and the department, we can directly retrieve the correct salary in constant time. This approach avoids nested loops, avoids complex condition checks, and keeps the logic simple and efficient. So let's move on to the coding part. Well, first things first, I'm gonna copy and paste this test case to the text file over here, and I'm gonna save it. Well, just write down the basic code first. In this case, we don't need the vector because we're gonna throw in the data directly to the unordered map right after we're making the unique key. So like I said before, we need the unordered map with the string type key and integer type of salary, which is value. I'm gonna call it salary database. And we have 6 employees. We need the data for name and department. And of course, salary. And then we need to make them key, which is called, I'm going to call it new key. So make key function with the parameter of name and department. And if the new key is made, we can directly throw into the salary database, right? Like this, new key with salary. There we go. This is how we register the salary in each key. And the make key function type would be string. And there's the new key, which is made with, I'm gonna throw in the return right away, the name and department. There we go. And then we have to make the target name and target department. So I'm gonna throw in Tom and engineering. And maybe we can get 8,000. So if salary database doesn't have the key for the target name and the target department, we have to make the key target key first with make key function, target name and target department. And if there's no value with the target key, I'm gonna print out employee not found message, and I'm gonna end this main function right away. Otherwise, I'm gonna print out salary. So it must be salary database with target key. There we go. So if I execute this file, oh, I didn't throw in this code to open the text file. There we go. The Tom in engineering department salary is 8,000. But what about Alex? Alex with engineering department, 5,000. as we expected. How about design department? There we go, 3,000. So we can do whatever we want, but it makes the unique key in each employee, so we don't really need to care about the same name issue. So there we go. Well, if we want to explore whole salary database unordered map, we can use the for loop. We don't really need this target related code anymore. We need to auto type. So just throw in salary database begin until we meet salary database end. We can increment the I, and we can directly print out I first. And maybe this is the key, and this is the value, which is salary. It must be I second. So in this case, in the unordered map, I first means that the key, which is made by make key function over here, and the value would be I second. So if I execute this file, it explores all the employees in the salary database. So this is the key, and this is the salary, which is value. So there are 6 employees as we expected. There we go. Well, this is our last example for today. In this example, the key is the release year of the car. But one year can have multiple cars, so unordered map is not suitable here because it allows only one value per key. So that's why we use unordered multi-map in this case. Each year maps to multiple car structures, and each car contains a model name and a price. And our goal is to retrieve all cars from a specific year. And I'm going to print out the values over here. So if I throw in 2021 as a target year, then it will print out AQD with the price of the car. But what about if I throw in 2020? There's no cars in that specific year, then I have to take care of the exception. So I'm going to print out the values according to the specific key, which is the release year of the car. So there we go. Well, first things first, I'm going to copy and paste this test data, save it. Sorry, this is not the text file. I'm going to paste it and save it. Well, I need the unordered map, specifically unordered multi-map, and I need the string. Well, first things first, I need the unordered multi-map with the key of integer type and the car type. So I'm gonna name it car database. I need the structure, which contains the model name and the price. Well, I need to open up the text file. With the read mode, and we need the year, which is the key, and we need the model name, which is the value 1, and the price, which is value 2. year, model, and price. There we go. And I'm gonna directly throw in to the car database using the insert. Year must be the key. And I need the target year, which is 2021, but I'm gonna test it with 2020 as well. And well, to get the specific year range, we need to use the equal range function, equal range. And if we throw in the target year for the parameter of the equal range function, it will return the starting point and the ending point of the specific year. So for example, if we throw in 2021 for the target year for the parameter of the equal range function, then it's gonna return this starting point, which is named as first, and the end point, which is named as second. So that's how we retrieve all the values in the specific year. But what about the 2020, which doesn't have any other values? Then the first value and the second value would be the same. So this is how we can do the exception handling, like this kind of year, for this kind of year, I mean. So for the exception handling for like year of 2020, if first and second are the same, then I'm gonna print out no cars found for this year, which is target year, like 2020. And I'm gonna end this main function right away. But otherwise, we need to retrieve all the values from the specific year, like 2021, 2022, and 2023 in this example. So first, until we hit second, and maybe we can print out the message like cars released in target year. Maybe you can print out the dash first. And just so you know, first is the key, which is already target year that we already print out over here. So we don't really need to print out I first in this case, but second would be the values. I'm gonna print out the model first, and maybe I can print out the dollar sign with my second price. Yeah, and then maybe this is all about the coding. So the target year now is 2021, so we can get the values for like this. As you can see, cars released in 2021 with the car name AQD. AQD. I'm gonna test it 2022. BC. Cars released in 2022 is BC. BC. And what about 2023? Model S. There we go. But what about 2020, which is our exception? No cars found for this year 2020. And you can test it whatever you want. There we go. Well, this is all about today's video, and I hope you find it very useful through this video. Thanks for watching, and see you on my next video. Bye guys.